Have you ever really thought about your t-shirt? I mean, not just the color or the fit, but the actual fabric itself. Well, it turns out there's a whole world of high-speed machines, mind-bending physics, and even artificial intelligence behind it. Today, we're pulling back the curtain on the hidden, high-tech science of making fabric. Let's jump right in.
So, it all starts with this one simple question. We're surrounded by this stuff every single day, right? Making it should be easy. But as we're about to see, what looks simple on the surface is actually an incredibly complex engineering puzzle. We're going to see just how deep this rabbit hole goes.
All right, let's get right to the main villain of our story today, the constant, relentless battle against tiny imperfections in textile production. I want you to think about the scale here. A single factory can churn out millions of meters of fabric a year. In that massive race, even the tiniest flaw, a single snapped thread or a small snag, is a disaster. It can grind production to a halt, waste tons of material, and ruin entire batches of product. So yeah, making flawless fabric isn't just an art, it's a monumental industrial challenge. And it turns out one of the biggest keys to getting that perfect fabric comes down to this single, critical variable that has to be balanced on a knife's edge. And that variable is tension.
And this right here, this is the heart of the problem. It's called warp tension. Just imagine a weaving loom, okay? It's juggling thousands of individual threads at once. Warp tension is the force that's keeping every single one of those threads perfectly straight and in exactly the right place. It's kind of the unsung hero of weaving, and getting it wrong messes up everything.
Which brings us to what I like to call the Goldilocks problem. It's so perfect. See, if the tension is too high, the yarns get super stressed and snap. The whole multi-million-dollar machine just stops. But if the tension is too low, the threads go all slack, they get tangled up, and they jam the machine. Both are terrible for business. The tension has to be, you guessed it, just right. So how in the world do engineers solve this incredibly tricky tension problem? Well, let's meet our first hero in this story, a predictive mathematical model. And this is where the whole game changes. Instead of just waiting for a thread to break and then scrambling to fix it, researchers started asking a much smarter question. What if? What if you could predict the problems before they even happen? What if you could build a perfect simulation, a digital twin of the loom to figure out the absolute best settings before you even flip the switch? So here's how they did it. Researchers at RWTH Aachen University basically built a mathematical clone of the loom. They analyzed every single moving part. Then, using some powerful software, they created a simulation that could calculate the tension on the threads at every single moment of the weaving process. And then, and this is the cool part, they let an optimization algorithm loose on it to run thousands and thousands of virtual tests, hunting for those perfect machine settings.
So, did it actually work? Oh yeah, big time. Just look at this chart. By using the settings the simulation found, they managed to drop the average warp tension from over 132 centinewtons all the way down to 106. That is a massive improvement.
But here's the really crucial part. It wasn't just about lowering the tension. The simulation found a way to make it more stable, more consistent. And the result? In their test runs, the fabric defects they were seeing before, they just vanished. Poof, gone. This digital twin could literally stop flaws before they ever had a chance to exist.
Okay, so prediction is amazing. But what about those super sneaky flaws that might still slip through? Well, that brings us to the next evolution in this fight for perfection, real-time detection.
And for that, let's meet our second hero. A company called Smartex came up with this brilliant idea, putting AI-powered cameras right inside the knitting machines. Think of them as a tiny, super-powered security team, an all-seeing eye that scans every single centimeter of fabric the very instant it's made.
So what are these AI eyes looking for? Pretty much everything. This data from a case study at a factory in Turkey is fascinating. A whopping 60% of the defects it caught were tiny issues with the machine's needles. Another 30% were problems with the yarn itself. And the last 10%? Things like small oil stains or holes that a human inspector might totally miss, but the AI spots them instantly. So what kind of impact does a system like this have on the factory floor? Well, in a study with a manufacturer called Impetus, the results were, frankly, staggering. They saw a 50% reduction in the number of fabric rolls that even needed to be checked by a human. By catching errors the second they happen, the system gives everyone confidence that the fabric is perfect, saving an incredible amount of time and money on quality control. So, let's put this all together.
What happens when you combine predictive math that prevents problems with an all-seeing AI that detects them? Well, you get the blueprint for the smart factory of the future.
So let's recap our two heroes, right? On one hand, you've got the simulation, the digital twin, that predicts the perfect setup to stop defects before they're born. And on the other, you've got the AI vision system that acts like a hawk, spotting any tiny flaw that might still happen in real time. It's a powerful 1-2 punch against imperfection.
And here's why this really matters. This is so much bigger than just making better t-shirts. This is a revolution in how we make things. It means less waste, less energy used, which is way better for the planet. It means better products for all of us. At the end of the day, it's just a smarter, more sustainable way of making the stuff we use every single day.
Which brings us to one last, really mind-blowing thought. We have systems that can predict the best settings, and we have systems that can see imperfections in real time. The next logical step sounds like it's straight out of science fiction. A factory that not only sees a problem, but automatically adjusts itself on the fly to fix it. A truly self-optimizing factory. Is that where we're headed? Now that's something to think about.